recording. Okay. Online simulators and my other references here for the binary search tree, material references, topic week 17. I forgot the other one. Find the predecessor and successor. Finding the predecessor and successor. And then later on I'll be posting my video demonstration. Okay. So let's start with I'll open the online simulators here, and then ayan, two online simulators and my reference. So let's start with this one. Binary search tree, or the BST. So basically, binary search tree is a data structure that quickly allows us to maintain a sorted list of numbers. So it is called the binary tree. By the way, for the binary tree, we can call binary tree because each tree node has a maximum of two children. It is called the search tree because it can be used to search for the presence of a number in logarithm time. By the way, this will be discussed in your advanced data structure, more on in a masteral degree and doctorate degree. But we will not be focusing on the logarithms, but we'll be focusing on the algorithms only. So the properties that separate a binary search tree from a regular binary tree is: number one, all the nodes in the left subtree are less than the root node, and the nodes in the right subtree are more than the root node. So both subtrees of each nodes are also BST, or the binary search tree. Example, they have the above two properties, meaning for number one, for example, all nodes in the left subtree are less than the root node. Example, so in this diagram, 8 will be our root node, and then if you will notice that all the nodes in our left subtree are less than the root node. Okay, so 1, 3, 4, 6 are less than 8, and then 1 is less than 3, and then if you will notice also, um, in this part, 4 and 6 are greater than 3. Okay, and then this one, all nodes in the right subtree are more than the root node. So if you will notice, 10 is greater than 8, so 8 belongs to the right subtree. So this is wrong. This is not a binary search tree, because if you will notice, yung 2 is less than 3. So supposedly 2 the will belong to the left subtree, supposedly. So that's why this is not a binary search tree. Okay? Ayan. Next. Okay, so the tree having a right subtree with one value smaller than the root is shown to demonstrate that it is not a valid binary search tree. So the binary tree on the right isn't a binary search tree. Isn't a binary search tree because the right subtree of the node tree contains the value smaller than it, which is 2. So there are two basic operations that you can perform binary search tree. Actually, it's not 2, it's 3 operations. Let's start with the insert operation. So inserting the value in the correct position is similar to searching, because we try to maintain the rule that the left subtree is lesser than the root and the right subtree is greater than the root. So we keep going to either right subtree or left subtree depending on the value, and when we reach the point left or right subtree is null, so we put the new node there. So this is the algorithm. I'll be explaining the algorithm later on. Okay, so for example here, ito na lang. Using the simulator here, let's say insert 8. Insert 8. So 8 will be our main root. Then next root to be insert is 3. Insert 3. Then next is 10. 10. Okay. So 3 is less than 8, so it will go to the left side, and 10 is greater than 8, so it will go to the right side. And then 1, insert 1. 1 is less than 8 and 1 is less than 3, so it will go to the left side of this 3. Next, 6. Insert 6. 6 is less than 8, greater than 3, so it will go to this side. Next, 14. Insert 14. So 14 is greater than 8, greater than 10, so it will go to the right side of this 3. Next is 7. Insert 7. So 7 is less than 8, greater than 3, greater than 6, so it will go to this side of the 3. Okay, so they are the same. There. So even in this example, in this simulator, insert 8. Oh, wait. Dapat clear. It's create empty. Insert. First element to insert is 8. 8 will be the root. Then next is 3 and 10. Insert 3. Then insert 10. Next, 1, 6, 14. Insert 1. Then insert 6. Then insert 14. Okay, 1, 3, 6, then 14. So 14 is greater than 8, greater than 10, so it will go in this side. Then 7. 7. No, 7. 7 is less than 8, greater than 3, greater than 6, so it will go in this side of the 3. Okay, next. So they are the same, and same. So that is for the insert operation. Now, if we take a look at this algorithm, if the node is equal to null, empty, then insert or create the node and insert the data. So for example here, the first node to be inserted is 8 and the root is empty. Kapag empty siya, then insert the element. Okay, next, if the data is less than, so if in case that the node is not empty, for example inserting 3, so basically the first node or root node is not empty anymore, then it will have a condition. We have a condition here that if the data is less than the node of the data, then go to the left side of the node. For example, 3 is less than 8, so it will go to the left side. Then insert the node left, insert the data, or yeah, insert the data 3 because this is empty. Next, insert 10. So insert 10. If we insert 10 here, 8 is not empty. I mean the main root is not empty. So it will have a condition if this belongs to the left side or right side. Based on the algorithm, if the data is greater than the node, then go to the right side and then insert the data. So this is not empty, so condition 10 is greater than 8, so it will go to the right side. Then if in case that this is empty, null, then insert the element. Next, for example, insert 1. So insert 1. The first data, I mean the first node, the parent node or the ground node is not empty, then we have a condition. If it is less than, so for example 1, so less than 8, so it will go to the left side of the tree. But the left child is not empty, hindi na siya empty because we have 3, element 3 in there. So compare, so 1 is less than 3, so it will go to the left side of the tree. Okay, then insert the element 1, and so on and so forth. Okay, so this is the algorithm for that. I have here also my module. This is my module. This one, binary search tree. So this is another algorithm. So if there is an if the tree is empty, then insert the new item in the tree node. So for example here, so if we will insert 8, and if the tree is empty, then 8 will be the parent node or the root node. Then insert. Then if the root key matches the new item keys, then skip the insertion. If the root key matches, meaning they are equal, pag equal daw sila, then skip the insertion. So if the new item key is smaller than the root key, so if in case that the node is not empty, pag hindi na siya empty, then it will check if the new item key is smaller than the root key, then insert the new item in the root's left subtree. But if otherwise, insert the new item in the root's right subtree. Okay, so same lang sila. Ayan. So this is the algorithm, and then this is another algorithm for that. Next is the deletion. Okay, before we start with the deletion operation or delete operation, let's talk about the search. Search operation. So the algorithm depends on the property of the BST, that if each left subtree has the value below the root, and each right subtree has the value above the root. For example, here the left subtree, if you will notice, all the elements in the left subtree are less than the element in our root. Okay, like for example 1, 3, 6, and 7 elements, these are less than 8. And then in the right side, 10, 14 is greater than 8, so it belongs to the right subtree. Yeah. Left subtree has the value below root, and each right subtree has the value above the root. So if the value below the root, we can say for sure that the value is not in the right subtree. Again, if the value is below, meaning less than. If the value is less than the root, we can say for sure that the value is not in the right subtree, because the elements in the right subtree are greater than, and we need to only search in the left subtree, and if the value is above the root, meaning greater than, we can say for sure that the value is not in the left subtree. So we need to only search in the right subtree. Okay, for example here, 4, we'll try to search element 4. 4 is not found, so traverse, meaning traverse visit. So 4 is not found in the main root, which is 8. Okay, 8. So 8, they are not equal, so 8 is not 4, so 4 is not found. Then visit through the left subtree, because 4 is less than 8, then it will go to the next, which is the left subtree, which is 3. Then 4 is not found because they are not the same. 4, this is not 4, so 4 is not found. So visit or traverse through the right sub 3. Why right sub 3? Because 4 is greater than 3. Okay. Yes. Then next is 6. Then 4 is not found because they are not the same. 6 is not 4, so 4 is not found. So traverse or visit through the left sub 3. Okay. So 4 is less than 6, so we have to traverse or visit the left sub 3. Next, then 4 is found because they are the same. Okay, so if the value is found, we return the value so that it gets propagated in each recursion step as shown in the image below. If you might have noticed, we have called the turn search or struct node 4 times. When we return either the new node or null, the value get returned again and again until the search root returns the final result. Okay, so the pattern is 8364. So here we traverse or visit 8, 3, 6, and then 4. Then in our diagram we have 8, 3, 6, and 4 to um, to call and return the value. Then you have to go back. So for example here 8364, then next is 836, 83, 834, 834, then next is 83, 8, ito pala 834, then next is 8, next is 8, then we have 4, so that we can call or return the value 4. But if in case that there is no element like that, then so when we return either the new node or null. Okay, so if in case that there is no element, that element in our tree, then it will return or call null. Example here, find, wala na yung 4, so insert 4 for example. Wala din dito, insert 4, 8 less than, greater than 3, less than 6, 4. So there. So if you will find 4, find greater than 8, greater than 3, greater than 3, less than 6, then 4. Found 4. But if in case that there is no element, like for example 2, okay, 2 is less than 8, less than 3, and 1, then no element found. Okay, or return null. Okay, so that is for the search. We have here an algorithm for the search. If the tree is empty, then the target key is not in the tree, right? Meaning if we don't have any tree, pag wala daw tayong tree, so basically if we don't have any tree, we don't have any element, for that the target key is not in the tree kasi wala naman yung tree. Next, if the target key is found in the root, pag nasa root daw siya, then the target key is found in the root item. For example, if we will find 8, find, so 8, because 8 is our main root, then we found the element. So here, if the value found, nasan yun? This one. So if the target key is found in the root, then the target key is found in the root item. Next, if the target key is smaller than the root key, then go to the left sub 3. And then if the target key is greater than the root, then go to the right sub 3. Example. So if we will find 14, so 14 is greater than the root, right? So find 14. So 14 is greater than 8, greater than 10. So and then 14 is found. If it is less than, for example, 7, then 7 is less than, greater than 3, greater than 6. So 7 is found. So this is the algorithm for the search. Now, the most complicated algorithm. The most complicated algorithm is the deletion. Let's start with this one. For the deletion operation, there are three cases or scenario for the deleting a node from the binary search tree. Example, in the first case, okay, the node to be deleted is left node. In such case, simply delete the node from the tree. What is leaf node? A leaf node, if it doesn't have any left and right childs or trees. So for example, here for the left, I mean leaf nodes. The leaf nodes are 1, 4, 7 and 14. Okay? Yeah. So 1, 4, 7 and 14, those are the leaf leaf nodes because it doesn't have any childs or left and right subtrees. Wala naman siyang child, wala din siyang left subtrees. Okay? There. So there are leaf nodes. And then if it is a leaf node, just simply delete the node from the tree. For example, if we want to delete 4, 4 is to be deleted, then that is a leaf node, then delete 4, just delete the node. Delete the node. Okay? Yeah. And delete the node. Now, for the second case or second scenario, in the second case, the node to be deleted has a single child node. Pag meron siyang isang child node or child node, in such a case, follow the step below. What is this one? Single child node. So in our example, the single child node are 6 and 10 because they have only one child. Isa lang yung child nila, right? So for that, follow the step below. Replace the node with the child node. Remove the child node from its original position. Meaning, for example, if you will delete or remove 6 from the tree, kung remove natin si 6, then the child will replace the deleted node. So here 7 will replace. Okay? 7 will replace 6 and then delete 6. So this is the final 3. So for example here, if we will delete 6, delete 6, delete. So delete 6 then replace 7. Okay? So that is the second scenario. Now the third scenario. So this is the more complicated scenarios. So in the third case or third scenario, the node to be deleted has two children or subtrees. In such a case, follow the step below. Get the in-order successor of the node, replace the node with the in-order successor, and then remove the in-order successor from its original position. Example. So in this diagram, we have 4. Delete 7. Ay, balik ko lang. 1, 6. So, insert 6. Then, insert 7. And insert 4. So, this is the 3. Okay, so for example, if you will remove 3, by the way, for this scenario, if the node to be deleted has two children, so for example, the nodes that has childrens are 3 left and right. We have 6 left and right. We have 8. We have left and right. Okay, we have two childrens or children. So if we will remove 3, who will replace 3? Get the in-order successor of the node. Replace the node with the in-order successor, then remove the in-order successor from its original position. Meaning, in our second reference, the second reference, finding the predecessor and successor node of binary search tree. So in this diagram, so if you will notice, ito pala. So we have the predecessor and then we have the successor. For the predecessor, we have this algorithm. One step left, then right till you can for the predecessor. Successor, one step right and then left till you can. Okay, so what we need here is the successor. So here, this is the successor. For example, who is the successor of 3? The successor of 3 is 34. Why? Because of this algorithm. So 3 step, 1 step right, 1 step right. Okay, and then left till you can. Then right, then left. But in this node, we don't have any left child or left subtree, so 34 will be the successor. Okay, next, who is the predecessor? One step left and right till you can. So one step left, then right, but we don't have any right tree here or right child, so 25 will be the predecessor. But in this case, what is important is the successor. Okay, again, in order successor based on this algorithm, case 3. So get, meaning this, the successor will replace the element to be deleted. Siya ang magre-replace. So in this example, who will replace 3? Sino magre-replace ng 3? So based on this reference daw, the successor will replace. Again, the successor is one step right and then left till you can. Step right, then left, which is 4, and then left, we don't have any left subtree here, so meaning 4 will replace 3. Okay, 3. So copy the value in order successor 4. So 4, tama, 4 to the node. So 4, so delete the in order successor, then so 4 will replace. Let's try that in our algorithm. Remove 3. Go. 3 will remove, who will replace? 4. So 4 will be the next parent node. Parent node. Okay, there. Using the successor. Nasaan yung successor natin? Using successor. Next. But in our next, the other simulator, if we will delete 3, pag delete daw natin si 3, who will replace? Based on this algorithm, we will the successor will replace the deleted element or node. Dapat akit si 4 doon. Delete 1. So if you will notice, they have different output. Okay, from this simulator, 1 replace 3, but in this simulator, 4 replace 3. So who is correct? Sino yung tama? Sino yung mali? Let's see in this, in my reference. Let me open my reference. First, we have scenarios, cases to consider. Deleting a leaf meaning no child. Pag wala siyang child, just delete, remove it from the tree. Deleting a node with one child, pag one lang yung child niya, remove the node and replace it with its child. But this is more complicated. Yeah. Deleting a node with two children, so call the node to be deleted and do not delete n. Instead, choose either in order, choose either in order successor or its in order predecessor. Okay, so either successor or predecessor. So based in our reference here, again the predecessor, one step left and then right till you can. So meaning here yung this one. The predecessor of 3 is 1. Bakit si 1 ang predecessor? Predecessor. Again, the predecessor, one step left, then right. But we don't have any right child, so meaning 1 will replace, or 1 will be the predecessor of 3. Okay, so both simulators are correct. Okay, so this is correct and this is correct, but they do have different algorithms that they used. So for example, in this algorithm, in this simulator, they use the successor. Okay, successor. Ito successor yung kinamit. Okay, but for this one, they use naman the predecessor. Kasi this is the predecessor. So predecessor will replace, or the successor will replace. There. Another example. If you will remove 8, this is successor successor to. Saan na yan? Yan. Get the in order successor. So successor will replace the deleted node. If we will replace the 8, we will remove 8. Who will replace 8? Sino magre-replace using the successor? So based in this reference, successor, one step right, which is 10, then successor pala yun, no? Predecessor, successor, one step right, then left. But we don't have any left child. So meaning 10 will replace 8 for the successor. Pag successor naman, yan. Let's see. So if we will remove 8, so 10 will replace 8. Go. 10 will replace 8. But here, who will replace 8? Again, for this simulator, they use the predecessor. So, sino ang predecessor dito? So, based in our reference here, the predecessor is one step left, then right. One step left, then right. Okay. One step left, 1. Then right, 6. Then right. Kasi sabi dito, it says here, then right till you can. Till you can. Hanggat meron. Okay? So, left, right, we have right child, we have another right child. And then we don't have any right child anymore. So, 7 will replace 8. Then let's see. So, delete 8. So, 7 is the predecessor, meaning 7 will replace 8. Delete 8. Okay? Again, both simulators are correct. But if you notice, they have different output because they do have different algorithms that they used. For this simulator, they use the successor. For this simulator naman, they use the predecessor. Okay. Yan. So